Pushkin. Irving Langmuir stood in the control tower at the airport at Schenectady, upstate New York. He was gazing intently upwards through binoculars at a little single-propeller aeroplane. Langmuir was in his mid-60s. Grey hair, round glasses, every inch the distinguished scientist. The year was 1946, a cold and crisp November morning, barely above freezing, with an almost completely clear blue sky. Almost. There were some clouds, 50 miles away, and that's where the little plane was heading. The plane had 4 seats. 2 were occupied. In one sat the pilot. In the other, Irving Langmuir's assistant, a man called Vincent Schaefer. He had with him a cardboard box containing 6 pounds of crushed dry ice and a motorised dispenser he'd rigged up back in the lab. The little plane had taken 40 minutes to climb to 10,000 feet, but the cloud that Vincent Schaefer wanted to fly into was higher still. "Can we get to it?" he asked. The pilot pushed the plane upwards. At 13,000 feet, they reached the cloud, just a little higher. Schaefer looked at his thermometer. Minus 17.5 degrees Fahrenheit, 27.5 degrees Celsius. He fired up the dispenser. Out into the cloud went the first pound of dry ice, the second, the third. Then the dispenser jammed. Schaefer was starting to feel dizzy. That's not surprising at 14,000 feet in a plane that isn't pressurised. Forget the dispenser. Schaefer opened the plane's window and tipped out the rest of the dry ice from the cardboard box. Back in the control tower, Irving Langmuir stared at the cloud into which the little plane had disappeared. Was it changing? Yes. Within minutes it began to shift and swirl, and then, out of the base of the cloud, came just what Langmuir had hoped to see. Snow. There was no mistaking it. He didn't even need his binoculars. From 50 miles away, you could see the streamers of snow with the naked eye. Before the little plane had even landed, Irving Langmuir was on the phone to a journalist. "This is history," Langmuir said. "Mankind has finally learned to control the weather." Of course, we hadn't. We just started to fool around with it. I'm Tim Harford, and you're listening to Cautionary Tales. In the early 1900s, General Electric was one of America's biggest companies. It liked to invest in what we'd nowadays call blue skies research. When the young Irving Langmuir left academia to start work at the company's campus in Schenectady, he was given the usual welcome speech. "Look around the lab," said Langmuir's new boss. "Work on any problem that interests you. Don't bother with finding practical applications. Let me worry about that. You just have fun." General Electric employed smart people and let them do pretty much anything they liked. And Irving Langmuir wasn't just smart, he was brilliant. He became the first industrial chemist to win a Nobel Prize for discoveries and investigations in surface chemistry. These discoveries did turn out to have practical applications. Langmuir's work let General Electric corner the market in gas-filled incandescent light bulbs. Not that Langmuir cared much about that. He thirsted for knowledge, pure and simple. Langmuir was the living stereotype of the absent-minded genius, famous for getting so deeply lost in thought that he could be oblivious to the world around him. There was the time a woman fell down the stairs right in front of him. As others rushed to help, Langmuir, in another world, didn't notice. He stepped right over her, kept on walking. And the time he forgot he was eating breakfast at home, not in a restaurant, and left a tip for his wife on the kitchen table. And the morning he turned up at work without his car. It turned out he'd been stuck in traffic and he'd simply left it in the middle of the road and walked. Now, in 1946, Langmuir had a new obsession: the weather. During the war, he'd worked with the military to study how ice forms on aircraft wings as they fly through clouds. Water, of course, turns from liquid to solid when the temperature drops below freezing point. Except, sometimes it doesn't. Clouds can be in a state called supercooled. The temperature drops below freezing, but the tiny water droplets won't crystallize from mist into ice unless something disturbs them. Langmuir and his assistant, Vincent Schaefer, both loved to ski. Their wartime work made them look at the clouds above the hills on a cold winter day and ask themselves, what if we could make those supercooled clouds dispense snow on demand? Remember, you could work on anything you liked at General Electric. Langmuir and Schaefer decided to work on making snow. Schaefer commandeered one of the chest freezers the company made. He lined it with black velvet so he could see if ice crystals were forming. Then he took a deep breath and breathed slowly out into the freezer. His breath hung there in a mist. Now he and Langmuir had their very own supercooled cloud, right there in the lab. What could they add to their cloud that might make it form ice crystals? They tried talcum powder, sulfur, magnesium oxide. No luck. Then, one summer day, the weather got so hot, the freezer started to struggle. Schaefer needed to keep the temperature down, so he got some dry ice. He dumped it back in the freezer, and all at once, millions of tiny ice crystals popped into being and settled on the black velvet lining. It looked magical. Vincent Schaefer had made snow in the lab. Could he and Langmuir make it snow in the real world? They waited impatiently for summer to turn to winter. They rented a little 4-seater prop plane, and at last, a day arrived that was cold and clear, with distinct clouds to aim for. Schenectady, New York, November the 14th. Scientists of the General Electric Company, flying in an airplane, conducted experiments with a cloud and were successful in transforming the cloud into snow. That's an announcement from General Electric. It had its own in-house news bureau to publicise all the clever things its researchers did. It helped the company's image. The press release stopped short of claiming that mankind could now control the weather. For all his enthusiasm, Langmuir knew they'd only done one experiment. Still, what promise it had shown. A single plane could generate hundreds of millions of tons of snow. Thus, a supply of moisture could be stored up for the spring months to feed irrigation and water power projects. Snow might also be produced at mountain resorts for the benefit of skiers. The next month, December, the little plane went up again with a bigger load of dry ice, on a day with more clouds in the sky. This time, it didn't snow straight away, but once it started, it didn't stop. Across Vermont and upstate New York, the snowstorm was epic. Dozens of cars crashed. Businesses had to shut up shop for a week. Langmuir was exultant. He called his boss, the head of the research campus.
"We did that."
The boss said, "Don't tell any journalists." The company's lawyers had started to think it might be unwise for General Electric to go around claiming responsibility for the weather. If they really had caused this snowstorm, that might not be good for the company's image with the people who'd crashed their cars or had to close their businesses. They might decide to sue. The boss hatched a plan. He called in the US military. Would they be interested in learning to control the weather? they would. The boss told Langmuir that he wasn't to meddle with clouds himself anymore. He could only advise the military. They would conduct the experiments, and with any luck, they would get the lawsuits if anything went wrong. Langmuir didn't mind that at all. The military, after all, had bigger planes. And Langmuir had big ambitions. He was already talking about making deserts bloom and learning to control hurricanes. What would happen if you dumped dry ice in a hurricane? He'd like to find out. You couldn't try that in a single-engined 4-seater prop plane. But you could in a bomber. Langmuir and Schaefer theorized that the dry ice might weaken a hurricane, but perhaps they shouldn't experiment on one that would soon make landfall, just in case. They needed a storm that was heading away from anywhere it could cause harm. In October 1947, they got their chance. Hurricane King had formed in the Caribbean. It had clipped the western edge of Cuba and curved over southern Florida, dumping vast amounts of rain. Now it was drifting out into the Atlantic, further and further away from land. It was an ideal test. From a military base near Tampa, 3 bomber planes took off and flew towards the hurricane. They were carrying 180 pounds of dry ice, a raft of scientific instruments to gather data, and Vincent Schaefer. They found the storm, 350 miles out to sea. They dumped the dry ice in it and flew around for a while, taking photos and making observations. Nothing too dramatic seemed to happen. They headed back to base. As soon as they'd turned their backs on Hurricane King, it did something nobody had expected. Cautionary Tales will be back in a moment. In her book, Under a White Sky, the author Elizabeth Colbert describes her encounters with people who work on geoengineering, ideas to fix climate change not just by reducing our emissions, but by intervening in the climate in some other way. Those ideas are controversial. The phrase "under a white sky" comes from a field of geoengineering called solar radiation management, shielding the Earth from sunshine to keep it cooler, like closing the blinds on your window on a summer's day. You could do that by shooting reflective particles into the stratosphere. One possible side effect is turning the sky white. Colbert talks with an academic who researches this idea. He gets hate mail, he tells her, even death threats. She also talks to a physicist who founded the field of negative emissions, basically sucking carbon dioxide out of the atmosphere. He came up with the idea after asking a friend over a beer, why is nobody doing these really crazy big things anymore? Colbert visits a startup in Iceland that's putting the idea of negative emissions into practice. Picture an air conditioning unit stuck on a shipping container. It sucks in air, uses a chemical process to extract the carbon dioxide, and injects it underground, where it turns to rock. The graduate students who founded the startup tell Colbert they faced a lot of opposition. People said, "Guys, you shouldn't be doing that." Those people weren't particularly worried that the Icelandic shipping containers would damage the planet directly. They were worried the shipping containers would foster complacency. We don't yet know how well these ideas will work. And if the general public gets the impression that scientists are going to figure out how to fix climate change, they might think, great, we don't need to worry about reducing emissions. But the idea of geoengineering wasn't always so controversial. In the 1950s, scientists in the Soviet Union had a problem they wanted to solve. The northern latitudes are a gigantic icebox. The icy breath of the Arctic is felt for thousands of kilometers around. It causes the permafrost over vast expanses of Soviet lands, the silent tundra, and the unexpected cold blasts, which are feared by Ukrainian horticulturalists. I'm quoting from a book called Man vs. Climate, published in Moscow in 1960. One co-author was Nikolai Rusin, an outstanding climatologist with over 50 scientific publications. The other, Leah Flitt, a journalist with good experience in the field of popularization of science. The book's publisher was so keen to popularize this particular science that they put out an English translation. The reader may ask, what sense is there in attempting to change the climate? Would it not be better to leave this to nature and wait and see? Of course not. The Arctic ice is a great disadvantage. So, what did Flitt and Rusin think we could do about the Arctic ice? They outlined several ideas being discussed by Soviet climatologists. You might scatter ash or peat dust. That would make the ice less reflective. It would absorb more heat and start to melt. Scientists estimate that 80 to 100 kilograms of dust or ash per hectare of ice ought to do the job. Alternatively, you might use potassium to create a high-altitude dust ring similar to that encircling Saturn. At the right angle, a ring around the planet would direct more sunshine onto the northern latitudes and warm them up. It would, admittedly, make the equator cooler too, but that shouldn't cause any problems we couldn't solve, as Flitt and Rusin explained. The Africans would require warm dwellings and entirely different clothes, shoes, etc. Flitt and Rusin describe another proposal for a 55-mile dam across the Bering Strait between Siberia and Alaska. Such a dam would change the direction of warming ocean currents, the central heating pipelines of our planet. Point those pipelines towards the far north, and in just 3 or 4 years, the Arctic would be completely free from ice. Building a dam to Alaska would need America's cooperation. Wouldn't that be unthinkable at the height of the Cold War? Not according to then presidential candidate John F. Kennedy. The idea of the dam, said Kennedy, was certainly worth exploring. Flitt and Rusin wax lyrical about the benefits. No more frost in Moscow. Orchards blooming in Alaska and northern Canada. All this is splendid, but is it really possible? Technically, yes. Nowadays, we often see in the news that Arctic ice is melting and permafrost is disappearing, and we tend not to think of that news as splendid. We worry now not about the cold, but global warming. You might assume that Leah Flitt and Nikolai Rusin hadn't heard of global warming. You'd be wrong. The book mentions the greenhouse effect, although the term is new enough that the translator puts it in scare quotes. Flitt and Rusin cite figures on carbon dioxide emissions that suggest that the mean temperature of the Earth's atmosphere will rise 4 to 5 degrees in less than 50 years. 4 to 5 degrees centigrade in 50 years. That's nearly 10 degrees Fahrenheit. Thankfully, it hasn't happened that fast. Not yet. But what fascinates me is the lesson the authors draw. The prospect of global warming doesn't scare them as it scares us. Quite the opposite. They see it as encouraging evidence that man can modify and hence control the climate. If we can affect temperatures so much as a mere byproduct of our everyday routines, just imagine what we might achieve if we actively put our minds to it. Presently available power resources and technological possibilities permit us to remake the climate of entire regions of the world. Just as today we plan the construction of new cities, so in the future we shall have to plan improvements in the climate. The things people used to believe. It's easy to mock them, but it also makes me uncomfortable, because We don't generally mock people for a sincerely held belief in the capacity of human ingenuity to make life better, especially not people who've proved their scientific chops, like Nikolai Rusin with his 50 publications, or Irving Langmuir with his Nobel Prize. The authors of Man vs. Climate share Langmuir's fascination with clouds. And not just with how to make them snow, but also how to make them disappear. Many regions of the Soviet Union are deprived of sunlight for several months. By destroying such cloud cover, man could substantially improve climatic conditions. Crops would ripen more quickly. When you read Man vs. Climate, there's no tone of self-awareness. No sense of, I know this sounds crazy, but hear me out. Instead, there's just a sense of calm, measured optimism. Clouds, fog, thunderstorms and hailstorms cannot be controlled in the same way as, say, hand or engine-driven machinery, and yet man will eventually learn how to control, or rather influence them, in the desired manner. Man will eventually learn to influence the weather and plan improvements in the climate. Nobody now thinks we can do any of that. Why did we lose that sense of ambition? That touching faith in the power of human ingenuity? Or, as the physicist who came up with negative emissions puts it, why is nobody doing these really crazy big things anymore? The day after he'd dumped dry ice on Hurricane King in a US Air Force bomber, Vincent Schaefer flew home from Florida to New York. He had planned to use the time on the plane to write up his notes. But in the sky high above Georgia, Vincent Schaefer's plane began to judder and jolt. Soon it was lurching violently. This was the worst turbulence Schaefer had ever experienced, and he couldn't write a word. He put down his pen and his notebook and clung to the armrests of his seat. Later, he found out what he'd been flying through. Hurricane King. What was it doing in Georgia? It should have been hundreds of miles away, heading further out into the Atlantic. The storm had done something completely out of the blue. It had abruptly turned back towards land, and far from weakening, it had picked up strength again. Hurricane King battered the coastline around Savannah with 100-mile-an-hour winds. It caused 12-foot storm surges. A falling tree killed a man. The storm destroyed crops and damaged hundreds of buildings, damage that cost millions of dollars to repair. Irving Langmuir was thrilled. We did that! The lawyers at GE were having conniptions again, but the dry ice had redirected the storm, accidentally. Langmuir was sure of it. And he was also sure that meant they could learn to do it deliberately, to direct storms exactly where they wanted them to go. Langmuir gave an interview to Fortune magazine. There is a reasonable probability, he told them, that in 1 or 2 years, man will be able to abolish most damage effects from hurricanes. Of course, we didn't. Cautionary tales will return. At General Electric's research campus, Irving Langmuir acquired another assistant, Bernard Vonnegut, brother of the novelist Kurt, who also worked for a while in the company's news bureau. Their time in Schenectady is described in Ginger Strand's book, The Brothers Vonnegut. Like all the smart scientists General Electric employed, Bernard was told, look around the lab and work on anything that takes your interest. Bernard was interested in Vincent Schaefer's freezer, lined with black velvet and containing a super-cooled cloud of breath. Schaefer had discovered that pellets of dry ice made the cloud in the freezer form snow. What else might? Bernard thought a rapid expansion of compressed air might do the trick. He went to a toy store and bought a children's pop gun for 75 cents. He lowered it into the freezer, pulled the trigger, and it worked. Millions of ice crystals popped into being. Something else made snow in the freezer too: silver iodide. One sub-zero winter night, as Bernard drove home from work, it occurred to him that the moisture in the air must be supercooled. What would silver iodide do to that? He got home, stuffed some newspaper and silver iodide into an oil burner, and carried it around. Before long, he got a call from his next-door neighbour, a colleague from work.
"Are you fooling around?"
said the neighbour. Why?
"It's a lovely clear evening, but I can't see your house."
Yeah, that was me, replied Bernard. I made the fog. In summer 1949, Irving Langmuir, Vincent Schaefer, and Bernard Vonnegut set up camp in New Mexico with their team from the military. Langmuir had dreamed of making deserts bloom. He wanted to see if dry ice could conjure rain from an arid sky. Bernard had brought along a silver iodide smoke generator he'd made in the lab. He told Langmuir he was going to set it going. Langmuir didn't seem to hear him. He was lost in thought again. At 6 a.m, Bernard got up and started the smoke generator. He sent up balloons to check which way the wind was carrying the silver iodide smoke. Towards the mountains. By lunchtime, clouds were building near the mountains, and was that thunder? It was nearly time for Vincent Schaefer to take off with dry ice in a B-17 bomber, so Bernard turned the smoke machine off. When Schaefer got to the clouds, he was surprised to find they were already raining. It rained, and it rained. That night, Bernard again told Langmuir that he'd been running the silver iodide generator. This time, Langmuir heard, and he was stunned. This was even better than dry ice. Bernard Vonnegut had made a thunderstorm. Why do we no longer aspire to influence the weather? There's an obvious answer. Despite what Irving Langmuir thought, we've learned we can't. But that's not quite right, because people still do seed clouds today with dry ice and silver iodide, and there's no scientific consensus on whether or not those people are wasting their time. Some say cloud seeding doesn't work. Others insist that it does, to some extent, in some conditions. I think that lack of agreement, after 3/4 of a century, tells us there's a deeper problem. This sort of thing is hard to test. You can't run controlled experiments on the weather or the climate. Every time Irving Langmuir picked up the phone to a journalist, the US Weather Bureau grew more and more exasperated. Their postbag bulged with angry letters. Why are you merely trying to predict the weather? Why don't you do something about it? The Weather Bureau tried to make Langmuir see that he couldn't make claims on one-off events. Would that thunderstorm in New Mexico really not have happened without Bernard Vonnegut's silver iodide? What about that huge New York snowstorm? Who could say for sure? Not the Weather Bureau. As for Hurricane King, nobody had predicted that sharp turn back to land, but that didn't mean Vincent Schaefer had caused it. Weather historians combed through the records and found that something similar had happened once before, in 1906. To find out if dry ice really could affect hurricanes, we'd need hundreds of storms to experiment on. But hurricanes are unique, and thankfully not common enough to provide a big enough sample size for experiments. Statistical analysis, said the Weather Bureau, was the only way to prove an effect. Ginger Strand describes how Langmuir took up the challenge. He devised an experiment. He'd run Bernard's silver iodide smoke generator on some days, but not others, on a regular weekly pattern. Would the rainfall also change on a regular weekly pattern? It did. But the Weather Bureau combed through their records and pointed out similar weekly patterns that had happened before. It might just be another coincidence. Irving Langmuir came up with new ideas to get statistical proof that he could make rain. But he discovered another problem. His penchant for publicity had inspired others. Freelance rainmakers were popping up everywhere, employed by farmers to water their fields or municipal governments to fill their reservoirs. Langmuir couldn't know if his own experiments were being affected by the people he'd inspired. And these burgeoning attempts to change the weather led to lawsuits, just as General Electric's lawyers had foreseen. After New York City employed a rainmaker, a huge storm caused a flood upstate. The city faced over 100 claims for damages. In the early 1950s, General Electric decided to pull the plug on Irving Langmuir's weather research. It was too much hassle. Langmuir retired from the company and went to work as a consultant for the army. They persevered for years, trying to turn weather into a weapon. In 1957, Langmuir died, still convinced that human mastery of the weather was just around the corner. In 1963, Bernard Vonnegut's brother, Kurt, published a novel called Cat's Cradle. It features an absent-minded genius of a scientist, a man who gets so lost in thought he abandons his car in a traffic jam and leaves tips for his wife on the breakfast table. In the novel, someone asks the scientist if it's conceivable for there to be a kind of ice crystal that would turn water solid at room temperature. The scientist discovers that such a crystal could exist in theory. Then, he makes it in the lab. When a crystal of Ice-9 is accidentally dropped in the sea, it turns all the planet's water solid, which wipes out life on Earth. Kurt Vonnegut later explained why Irving Langmuir had inspired his fictional genius. Langmuir, he said, was absolutely indifferent to the uses that might be made of the truths he dug out of the rock and handed out to whomever was around. Any truth he found was beautiful in its own right, and he didn't give a damn who got it next. The moral of Kurt Vonnegut's novel is that some scientific knowledge shouldn't be pursued. And I think that's a big part of the answer to the question, why is nobody doing these crazy big things anymore? It once seemed like part of our human destiny to learn to control the weather and remake the climate. As the decades went by, more people began to think, if we try, we're bound to screw things up. The sense that some knowledge shouldn't be pursued explains the hate mail for the academic who studies solar radiation management. These ideas are hard to test, so we can't be sure of the risks unless someone does it for real. And the more academics debate the theory, the more tempted someone will be to give it a go. But attitudes to geoengineering are starting to change again. The idea of negative emissions has already become part of the mainstream. When the graduate students in Iceland set up their shipping containers to suck carbon out of the atmosphere, people said, "Guys, you shouldn't be doing that." The critics thought it was knowledge that shouldn't be pursued. Now, we rely on that knowledge being found. When climate experts say there's still hope to avoid runaway warming, they're assuming we can make negative emissions technology work on a big enough scale at a low enough cost. That's still far from certain. And what about the more outlandish schemes, like reflective particles in the stratosphere? Will they become mainstream too? Researchers in Germany recently asked climate engineering experts how other scientists saw their field. Compared to just a few years ago, they said, others had become much more open to their research. But that's not because the other scientists find geoengineering schemes any less disastrously risky than they did before. It's because they know we've wasted our best chance to stop climate change by acting more quickly on reducing emissions. So much future warming is now locked in. The temptation to try some ambitiously large-scale geoengineering projects might become irresistible. Perhaps it now makes sense to pursue the knowledge in the hope that we can minimise the risks. It's poignant to look back on the 1940s and 1950s, when scientists like Irving Langmuir and Nikolai Rusin dreamed of remaking the climate. They had a touching faith in human ingenuity, but we now know that it's a far more complex challenge than Langmuir or Rusin imagined. And yet, we've left it so late that all that remains are a set of bad options. So if we try to remake the climate, we'll have a different motive. It won't be aspiration, but desperation. I very much enjoyed Ginger Strand's book, The Brothers Vonnegut, while researching this episode. For a full list of our sources, please see the show notes at timharford.com. Cautionary Tales is written by me, Tim Harford, with Andrew Wright. It's produced by Alice Fiennes, with support from Edith Rousselot. The sound design and original music is the work of Pascal Wise. Julia Barton edited the scripts. It features the voice talents of Ben Crow, Melanie Guttridge, Gemma Saunders, and Rufus Wright. The show wouldn't have been possible without the work of Jacob Weisberg, Ryan Dilley, Greta Cohn, Lital Millard, John Schnaars, Carly Migliori, and Eric Sandler. Cautionary Tales is a production of Pushkin Industries. It was recorded in Wardour Studios in London by Tom Berry. If you like the show, please remember to share, rate and review. Go on, you know it helps us. And if you want to hear the show ad-free, sign up for Pushkin Plus on the show page in Apple Podcasts or at pushkin.fm/plus.